My name is Anay Sunny. My project is reinforcing synthetic data of patients suffering from liver cirrhosis. So, liver cirrhosis is a serious and progressive condition where healthy liver tissues is gradually replaced by scar tissue. So, this project is focused on the reinforcement and enhancement of synthetic data. Synthetic data is like artificially generated but realistic patient data. So the data set I have taken from the Kaggle. So that is I have mentioned here. And these are the features that is from the data set. And these are the libraries imported, pandas, numpy, seaborn for visualization and everything mentioned here. Then reading the data set from GitHub, then pre-processing it. This is the displaying the first 5 rows. Then this is like the data types displaying and the null values. So we can see the null values, and then all the null values are replaced with mean. Then the gender value that is also changed, male as 1 and female as 0. And then displaying the first 5 rows again, then taking the info. So memory usage is like 50.2 KB. Then these are the feature that is also describing here, and then dropping the duplicate values, then taking the info again. That is from there we can see that the memory usage is like around 53.4 KB. Then next is like feature engineering. Here log is applying for skewness. Then the age group is taking like 0 to 18, 18 to 35, 50 to 90, something like that. Then bilirubin ratio, that is the total direct bilirubin that is divided by the total bilirubin plus 1e minus 5. This is adding the epsilon to avoid the division by 0. Then enzyme sum, that is a new feature. Then it is like next cell is about the outlier capping. Then displaying the rows again and taking the info. Then next is like correlation check with the liver disease. So it is what mentioned here, it is displayed here. So we can see that it is like calculating the how strongly each feature in the data set is related to liver disease. So here it is like +1 and 0 and -1. So +1 it is like the strong positive relationship, and the 0 is like no relationship, and the -1 this is like a strong negative relationship. So these are the red colors, and it is like a strong positive correlation, and the blue colors are like strong negative correlation. Then these light colors showing like the weak or no, not at all correlation. So next is like the full correlation matrix. So this is showing the the relations between the features. So diagonally it is represented. Then next is visualization. Here the distribution of age. So from this age distribution we can see that, see this one, this is in between the age of 40 to 60. The liver disease chances is like high, that is what mentioned here. Then gender distribution from the data set, the data of the female is like around 150 and the male is the high. Then liver disease also plotted here, I mean the female and male based on the gender. Then based on the total bilirubin, when it is high, the liver disease chances is also high. Then next is like plot of important features. So it is like each small graph compared to features like age and total bilirubin or direct bilirubin. So the points are colored, that is based on whether the person has liver disease or not. So for example, it is like the blue, it could be no disease, and the orange, these and these has disease. That is what mentioned. That is also mentioned here. Then on the diagonal, so it is like the it have a smooth curve. It just shows the like the distribution of each feature. So that is what showing. Then next is like distribution of alkaline phosphates. So it is like these bars represent how many people have certain range of values. Is like, for example, the value between 100 and 150, or between 150 and 200, like that. Then next is the violin plot. It has shows the distribution of alamine. So people without liver disease and those with liver disease, that is the one that is here representing. The shape of the violin represent the distribution of the value. So how the enzyme levels are spread out. It is like showing here. The next is the joint plot. So joint plot showing the relationship between age and total bilirubin levels. So each of the these kind of dots, these representing the patients. Next is the scatter plot. So in the scatter plot, this blue line shows the general trend. So it is the line of the best fit. It is like the meaning is like uh, whether there is a positive or negative relationship. Then next is like the box plot of ALT and AST by liver disease. Then SWAM plot. This is like total proteins by liver disease. The next is normalization and data splitting. Data splitted like 20% for testing and 80% for training. Then SMOTE, it is a data balancing method to deal with the class imbalance. So that is what it is showing like before SMOTE and after SMOTE. So these are the algorithms. So here starting with the random forest. So in random forest, first of all, taking the technique SMOTE, so it is up, it is showing like so random forest without SMOTE. That is what showing the random forest. The accuracy without SMOTE is 72%. Here it is showing, and the issue is like poor performance for class 0, because when we check the confusion matrix, we can see that only 7 out of 33 uh, predicted correctly. So no effective for the handling the class imbalance is not effectively happening, especially for the class 0. So after applying the SMOT, the accuracy is increased to 73%, and the minority class, the low recall is 42%. Uh, that is here mentioned, and the SMOT provides some improvement, but still not fully effective for class 0, but it provides some improvement before applying SMOT, better than that. And next is like logistic regression. In the logistic regression, the accuracy is around 72%, and in the when we check the confusion matrix, it is like 11 out of 33 class predicted correctly. So good for the class 1, but class 0, it is a poor performance. So this is like after applying SMOT, the accuracy increased. We can see that it is 73%, it is increased. So next is like decision tree, that is without SMOT. Without SMOT, the decision tree accuracy is 61%. So here also only 9 out of 33 class predicted correctly. So there is a poor performance. Then after applying SMOT, after applying the SMOT, there is a increase in the accuracy. It is accuracy increased to 65%. So it is like 10 out of 33 class 0 predicted correctly. So there is a minor improvement happened. Uh, then next is like SVM. SVM without SMOTEC, the accuracy is 71, and so in 71 it is like 0. So it is we can say that no effective class predicted, heavily biased towards the class 1 because there is no correctly predicted class. Then after applying the SMOT, accuracy increased to 74, and 26 out of 33 class 0 predicted correctly. So it become more balanced, and but still a little bit favored to the class 1. The next is like neural network. Neural network accuracy is 0.70 without SMOTEC. So there is strong bias because mm, no class, I mean, see, there is no prediction correctly for the class 0. Then after applying the SMOTOMIC, it is like the accuracy increased to 76%, and 24 out of 33 class predicted correctly. Then next is like we are moving to the another technique, VAE. So other than SMOT, VAE is also used for all the algorithms and model, VAE is also applied. So this is the before this is the original training data, and after the balanced we can see the difference. And then random forest with the VAE, that is the accuracy is around 72%. So 7 out of 33 class predicted correctly. Then VAE is applied to the random forest. So then when we check, the accuracy increased to 76%, 14 out of 33 classes, class 0 predicted correctly. So it is like the accuracy is increased, and there is a better improvement we can see. Then next is logistic regression. So it is like the accuracy without VAE is 72%. Then recall is about 33%. Then logistic regression with the VAE, the accuracy increased to 71. And it is like around 23 out of 33 class 0 predicted correctly. So VAE, it offers a better balance, but the performance for class 0 is not ideal, even though the accuracy is increased. Then decision tree. Decision tree, the accuracy is 61%. Then it is increased to 65 after applying VAE. Then next is SVM. SVM without VAE, the accuracy is 71%, and no class 0 predictions. So it is heavily biased towards the class 1. After that, applying the VAE balanced to the SVM, the accuracy is increased to 69, and 11 out of 33 class 0 predicted correctly. So next is like neural network. So we can see before applying the VAE technique, accuracy is around 71%, and biased towards the class 1 because no class 0 predictions. And then I have applied the VAE technique to neural network. Then the accuracy is increased to 75%, and 15 out of the 33 class 0 predicted correctly. So VAE improves the class 0 prediction. We can see that. So neural network with VAE, it is shows the balanced data, and random forest with the VAE. These performed the best actually in these models. This performed the best with SVM, more than SMOTE. It is performed well with SVM. So that is what understood from this. So this is my project. Thank you.